Okay, welcome to part 2 of 5.7. All right, so continue taking notes. 5.7, part 2. And this is, we already did difference of two squares, so I'm just going to write this part of the title, sum and difference of cubes. Okay, so we listed our perfect squares last time, which are probably a little more well-known, the perfect squares. Let's do some of the cubes. Okay, some perfect cubes. So one to the third power is 1. 2 to the third power, 2 times 2 times 2, that's 8. 3 to the third power, 3 times 3 times 3, that's 27. 4 to the third power is 64. 5 to the third power is 125. And that's all I know up to. All right, that's all I have memorized. Okay, all right, and then you can list you yourselves. You can list more of them if you want to. That way you have quick access to them. That way you can recognize whether or not you have a perfect cube, and you can factor. Okay, all right. So let's take a look here. So we have the sum and the difference of cubes. Okay, and so just like the difference of squares, we have formulas for factoring. So just like squares, you first identify what is being cubed, and then you can factor it. Okay, so this one, I would highly recommend that you spend more time to really mastering this one. Everyone masters the difference of squares. It's quite easy. But the sum and difference of cubes is where students will forget how to factor this. Okay? All right, so if you have something that's being cubed, identify it. And then same thing here. Once you identify what is being cubed here and what is being cubed here, then you'll be able to come up with your first factor. So it turns out that when you factor difference of cubes and sum of cubes, then you end up with a binomial and then a trinomial. Okay, so when you identify what's being cubed here and here, you should be able to come up with your binomial. It's going to be x minus y. Okay, so far that looks pretty simple, right? Identify what is being cubed here, identify what's being cubed here, and that should match up here, right? If this is subtraction, this is subtraction. Okay, and then when we do sum, then the binomial will also be a sum. Okay, but let's focus here. All right, and then you can move away from here now and just focus on your binomial here. So to come up with the 3 terms in the trinomial factor, each term, it's like each term has a formula, and the formula for each term is based around these guys here. Okay, so the formula to find the first term is to square the x, whatever the x is, right? The way you find the middle term, by the way, it's going to be positive. Okay, and the way you find your middle term is by taking the product of x and y. Okay, and the way you find your third term is by squaring the y. Okay, so each one of these acts like a formula to find each term in this trinomial. So it's basically square, take their product, square, right? Square, take their product, square. Okay, and then for the sum of two cubes, very similar. You first identify what is being cubed. And then once you identify what's being cubed, you will have a binomial here. Okay. And then using your binomial, you can come up with your trinomial. Okay. It's very similar to this one. The only thing that's different is that here for the sum, when this is a sum, this will actually be negative. So you'll still have x squared, but here you'll have a negative, a subtraction. And then you still have x, you take their product, xy. And then this is still plus. Okay? So if it's a difference, the binomial will be a difference. If it's a sum, the binomial will be a sum. And just remember, these two will be different. These two will be different. Okay? That's one way to look at it. All right, so these also need to be memorized. This one more so than the other one, because the other one you're going to do it, it's going to be so easy that you will have remembered it after doing like 3 or 4 problems. But this one, for some reason, just by looking at students' tests over the years, they kind of mess up on this one. Okay, so make sure you memorize this. All right, let's take a look at some examples. Factor completely. Okay, so let's take a look at this first example. X cubed minus 1. Okay, so clearly these are both cubes, right? Identify what's being cubed here and identify what's being cubed here. So here, x is being cubed. Here, 1 is being cubed. Okay, so if you can identify what's being cubed, then that's what's going to go in here. So we see x is being cubed, so x goes there. 1 is being cubed, so 1 goes there. And remember, if this is a difference, a subtraction, then your binomial will be a subtraction. Okay, now let's go ahead and find the trinomial part. So remember, you take the square, and then you take their product, and then you take the square. Square, product, square. So this first term is going to be x squared, and then we'll have plus, and then I'll go ahead and multiply these. It's always going to be plus, okay? So that's just going to be x, and then I square this, so that's going to be plus 1. And that is it, okay? So that's your final answer, and this trinomial won't factor, okay? So you can just leave it like that. This is not like the trinomials from 5.6. This is a trinomial that is not factorable. Because if it were, then they wouldn't give us this. They would give us the more factored form of it, right? Okay. All right. Let's try this one. X cubed plus 27. Okay. So identify what is being cubed here. That would be x. And identify what's being cubed here. That would be 3. Okay, again, if you don't have them memorized, then at least write down the first like 8 of them. Okay. All right, so we said x is being cubed and 3 is being cubed. X is being cubed and 3 is being cubed. And if this is a sum, your binomial will be a sum. Okay. All right, let's go ahead and find the trinomial part. Okay, so square and then take their product and then square. All right, so let's square the x. Now this is going to be subtraction. Take their product, it's 3x, and then square the 3. Okay? Let's try another one. Let's take a look at this one. 27a cubed minus 8b cubed. Okay? So identify what's being cubed here. That would be a 3 and an a. 3a. Okay, so 3a is being cubed here. And over here, 2b is being cubed. Okay? All right, so now let's come up with the trinomial using what we have here. Okay, so the first term over here, we square this. So 3a times 3a. 3a times 3a. That's 9a squared. Then it's going to be plus. And I take their product. 2 times 3 is 6. So I'll get 6ab. It's going to be plus. Now I square this one. So remember, it's square, take their product, square. Okay, so over here, 2b times 2b is 4b squared. Okay? All right, and I want to talk about this next one here because 64 minus m cubed. Okay, so make sure you have these in the right order. Okay, so oftentimes students will want to go, oh, I'm going to go ahead and rewrite that as m cubed minus 64. Nope, do not do that. Do not do that. Okay, subtraction is not commutative, which means subtraction, you're not going to get the same answer if you switch them. Okay, I mean, just think about it. If you do 5 minus 3, you get 2, right? If you do 3 minus 5, you don't get 2, you get negative 2. Okay, so that's a big difference if you're doing accounting, right? Okay, so don't switch it around if it's subtraction. Addition, fine, but subtraction, no, do not switch that. So you have to keep it in that order. Okay. All right, so let's identify what's being squared here. 4. So 4 needs to go first, not m. Okay. The m has to go second. All right, let's come up with our trinomial. So square this. So 4 times 4 is 16. And then plus, take their product, 4m, plus, square this, m squared. Okay, so that would be it. Okay, and let's do one more. Okay, I'm going to have you guys try it. So try this one. 125 plus 27 c cubed. Okay. All right, so go ahead and hit the pause button. Okay, so here, identify what is being cubed. So over here, that would be 5. It's going to be plus. And then over here, this would be 3 and c. So 3c. Okay, so now we can come up with our trinomial using our binomial. So square this. 5 times 5 is 25. And then minus, take their product. That would be 15c. And then square this. 3c times 3c is 9c squared. Okay? And then as far as 5.8 goes, it's just putting all of your factoring techniques together. So make sure that you factor completely. Okay, so that's pretty much it for perfect cubes. But let me give you some examples where, okay, you might have to factor some more. Okay, so that's what we mean when we say factor completely. You might factor once, but then your answer can still be factored some more. So let's take a look at those examples. So factoring completely. Okay, so like I said, before you start, always check for common factors. So far, we haven't had many. Check for common factors. Okay. And then after, check if still factorable. So maybe you have difference of squares. Okay. Or maybe you have difference of cubes. Okay. So let's take a look. And we'll just do 3 examples here and then we'll end. Okay, factor completely. All right, suppose that I have this. X to the 4th minus 1. Okay, so here, this is actually difference of squares, right? Here, what's being squared? X squared is being squared, okay? So here, it's going to be x squared plus 1, x squared minus 1. So this is from part 1, right? Difference of squares. This is the easy one, okay? It's x squared plus 1, x squared minus 1, okay? So now we did that. We did the factoring of difference of squares. But now take a look at your answer, okay? So here, notice that this one, we have difference of squares. So here, you can still factor. Okay, so I'm going to go ahead and bring this one down. And this one is perfect squares, so it's going to be x plus 1, x minus 1. And then nothing else is factorable, so this would be our final answer. Okay, so that's what we mean by make sure that you can't factor anymore. Okay, all right, let's take a look at this one. A to the 4th minus 81. Okay, so same thing like up here, a squared is being squared, and over here, 9 is being squared. So we have difference of squares again. So this is going to be a squared plus 9, a squared minus 9. Okay, and again, right here, you can still factor because we have difference of squares here. Okay, so I'm going to bring this one down. And now this one is going to be a plus 3, a minus 3. And then nothing else factors. So that is it. Okay. And let's take a look at this one here. 2x to the 4th y minus 32y. Okay. So here, they actually have stuff in common. Okay, so starting with the numbers, they have 2 in common. Okay, so they have 2 in common, and they also have y in common. So I'm going to go ahead and factor out a 2 and a y. Okay, so now let's figure out what goes in here to get this back. So I have a 2y out here, and I need to make all of this. So this is going to be x to the 4th. So that when I multiply this out, I get 2x to the 4th y. Okay. over here, when I multiply 2y times over here, I should get 32. So 32y. So that's just 16. Because 2y times 16 is 32y. All right, but we are not done because over here, these are perfect squares, right? Perfect squares again. Okay, so I'm going to go ahead and factor this out. So it's going to be x squared plus 4, x squared minus 4. Oh, but look it. We have perfect squares again. Okay, so I'm going to go ahead and factor some more. This one doesn't, because remember, sum of squares does not factor. But difference of squares does. X plus 2, x minus 2. And nothing else factors, so that would be it. Okay, so that is it. Again, if you have questions, make sure you text me or email me.